Hi, hello, welcome back, students of grade 10. In this lecture, you are going to see your science chapter 10, light reflection and refraction, fill in the blanks. Here, in total, 25 fill in the blanks you are going to see, which will be important in terms of VSAQs, and all fill in the blanks will be explained in English. That will be so important for your board examination. Without doing any late, let us jump into the topic. Let us see first question. Two immiscible transparent liquids A and B have 1.2 and 1.4 as their refractive indices with respect to A. The refractive index of B with respect to A. If you have seen that MCQs which I have uploaded earlier, that video, there I told you a concept. If they ask refractive index of B with respect to A, how to take? Refractive index of B with respect to A, that should be in denominator. What is the refractive index of B? That is 1.4 divided by A refractive index is 1.2. You have to go with an answer. What you can do, you can multiply and divide with 10. You will get 14 by 12. 2 6 12, 2 7s 14. So you can write answer as 7 by 6. If they give any options related to decimals, then what you can do, 6 7 6 ones 6, 1 is the remainder, 0.0, 6 ones 6, 4 is the remainder, 0.0, 6 6 36, 4 remainder, again 636. It will be going on. So you can write answer as 1.1666 or 1.17 is the answer. Number 2, the power of a convex lens is dash and that of concave lens is dash. You see, power, we know formula, power is equal to reciprocal of focal length. We have to say whether which one is positive, which one is negative. We know in case of convex lens, if a light ray is passing parallel to principal axis, that converges, and you can find focus here according to the Cartesian plane. If you are taking this direction, this is positive. So in case of convex lens, it is positive, and in case of concave lens, so this is concave lens. And if a light ray passing parallel to principal axis, light ray gets diverged, and if you draw imaginary lines, focus you can find here, so according to the Cartesian plane, if you are moving in this direction, it is negative. So answer here will get negative. So what answer you have to write? Positive comma negative. Next, third question. Light seems to travel in, very direct question, straight line. So always light travels in straight line. Power of lens is reciprocal of, if you see here, what we have discussed, power of lens is reciprocal of focal length. So here capital F stands for focus, small f stands for focal length. So answer is focal length. The SI unit of power of a lens. So power SI unit is diopter, spelling D-I-O-P-T-R-E, diopter, or symbol capital D. So you can write it as power is equal to 2 diopter or power is equal to 3 diopter, etc. Sixth question. The center of the reflecting surface of a spherical mirror is a point called spherical mirror. There are two types of spherical mirrors. First one is concave mirror. Second one is convex mirror. Whatever mirror you take, if you draw principal axis, exactly we will draw center to the mirror. This center is known as pole, P-O-L-E, pole. So here also same thing you can get, pole which is represented with the letter P. So that central point of spherical mirror is known as pole. The mirror used in construction of shaving glasses is dash mirror. We have two mirrors, concave and convex. In these two mirrors, which one they will use? You see, In shaving glasses or in case of dentist to check our teeth, they will go with concave mirror only. Why? Because every time we need to get image, that image should be virtual, erect, and main important, enlarged. This virtual, erect, enlarged image we can get in concave. So answer is concave mirror. Number 8. An object is placed in front of spherical mirror. The image is found to be virtual for all positions of the object. The spherical mirror is. So there are two types of mirrors, concave and convex mirror. And if you observe images, while coming to concave, we have 6 positions. And while coming to convex mirror, we have 2 positions. In these 6 positions, in 5 positions you can find images real, right? But in only 1 position we can get virtual. In case of this convex mirror, we have 2 positions. All these 2 positions you can get virtual images only. So what they asked, an object is placed in front of some spherical mirror. The image is found to be virtual for all positions, whatever it may be the position, and the answer would be convex mirror, or you can write the spherical mirror is convex, enough. The angle of incidence is dash to the angle of reflection. Very direct question. If you take, this is mirror and this is back surface of the mirror, normal ray, incident ray, and this one is reflected ray. And incident ray, reflected rays, that if you go with angle of incidence and angle of reflections will be equal, or you can write same. 10th question, the reflecting surface of a spherical mirror may be curved dash or dash. So why it is called a spherical mirror? We know, consider this is plane mirror. This plane mirror, if you bend it inwards, I mean, of course you cannot bend it. If you bend it will break. So if a mirror which is bent inside or inwards, I mean like this. So this is non-reflecting surface and this side is reflecting surface. This one is known as concave mirror. And if a mirror which is bent outwards, this is non-reflecting surface and front side is reflecting surface, this is convex. So the reflecting surface of a spherical mirror may be curved inside or outside, or you can write it as inwards or outwards. That is the answer. 11th question. The surface of the spoon can be approximated to a dash mirror. If you see spoon, if you take steel spoon which is there in your house, if you see this surface which will be hollow inside, not hollow, I mean some depth you can find inside, and that resembles concave mirror, isn't it? So surface is known as concave mirror. But if you observe this one, it acts as convex mirror. Next, 12th question. Line passing through the pole and center of the curvature of a spherical mirror is called. So whatever spherical mirror you want, you can consider this concave. This is non-reflecting surface, front side is reflecting surface, middle point of the mirror is known as pole, and here there will be focus for the mirror, here there will be center of curvature. If you draw a line which is passing center of curvature, focus, and if it is touching pole, this line is known as principal axis. It is principal axis. That is the answer. Next, 13th question. Parallel rays of light are reflected by a concave mirror to the point called dash. The focal length of distance from the dash to the pole of mirror. Okay. The parallel rays of light reflected with the concave mirror. Let us consider this is a concave mirror, and there are few parallel light rays. One parallel light ray, second parallel light ray, here third parallel we can take, fourth. After touching the mirror, what will happen? All light rays will pass through a point here, isn't it? This light ray will pass like this, this light ray will pass like this, and this point is known as parallel rays of light or reflected by a concave mirror to the point. called, that is focus point, or simply you can call it as focus. The focal length, what is focal length? You see, this is principal axis, this is pole, and this is focus. Distance from focus to pole of a mirror is known as focal length, f. So the focal length is the distance from focus to the pole. Answer is focus. Light is a form of, very direct question, energy. Light is a form of energy and it travels in a straight line. Simple question. 15th, a light ray or a ray of light passes dash after refraction through the optic center of a thin lens. So if you take lens, for example, you take convex lens, this is optic center, and if you pass a light ray, and if a light ray is passing through optic center, what will happen means, without any refraction, without any deviation, that light ray passes in straight line, whatever it may be the direction. If you pass like this, definitely passes like this. If you pass a light ray like this, definitely it passes like this, right? So here a ray of light passes straight. That is the answer. Straight after refraction through the optical center of thin lens, whatever it may be the lens, either concave or convex lens. 16. A ray parallel to principal axis after reflection will pass through the dash. Reflection, they are saying reflection means you can go with the mirror. Again, we have two types of mirrors, concave mirror, at the same time convex mirror. Whatever it may be the mirror, either you take concave mirror or you take convex mirror. If a light ray which is passing parallel to the principal axis, after touching the mirror, what will happen? It passes through focus. Here also, if a light ray which is passing parallel to the principal axis, of course it diverges like this, but that if you draw imaginary line, that passes through focus. So answer is passes through focus. Next, sin I by sin R is equal to mu is called, straight direct question in your textbook, is known as Snell's law. Snell's law. 18th, a light ray traveling obliquely from denser medium to a rarer medium bends dash to the normal. When it travels obliquely from rarer to denser medium, what will happen? Okay, let us try to understand small experiment, that is light passing through rectangular glass slab. Let us consider we have a rectangular glass slab here, and this is the point where you can draw a normal ray. Here this is incident ray which is passing. So first of all, this is air, you can consider this one as rarer medium. This is glass, you can consider this one as denser medium, and this is again air, which you can consider it as rarer medium, isn't it? Now this is incident ray which is passing from rarer to denser. Instead of traveling like this, what will happen? That bends like this, isn't it? Now here another point where you can draw another normal ray, and again you see light is traveling from denser to rarer. Instead of traveling like this, light ray bends like this, it will travel. This is incident ray, this is refracted ray, this is emergent ray. Now you see, instead of traveling like this, light ray is bending towards the normal here. So when a light ray is passing from rarer medium to denser medium, light ray, instead of traveling like this, that is bending, it is shifted towards the normal. So you can write towards normal. Now if a light ray is passing from denser medium to rarer medium, here denser to rarer, instead of traveling like this, which is getting away from the normal, moving away from the normal. So moving away from normal. Here what we can write? A light ray traveling obliquely from denser medium to rarer medium. So this one is denser to rarer, bends away the normal. When it travels obliquely from rarer to denser, dash. When it is traveling from rarer to denser, it will bend towards the normal. Like that you can go with the answer. 19. In case of a rectangular glass slab, the refraction takes place at both dash interface and dash interface. The emergent ray is dash to the direction of incident ray. So here, in case of rectangular glass slab, the refraction takes place both at, you see, this is the line which is separating both mediums. Here we have rarer medium, denser medium. Rarer medium is air, denser medium is glass. So what we can say, it is here both air glass interface, and again from here to here it is moving, right, from denser to medium. So you can say glass air interface, air glass interface and glass air interface, that we have to fill in this. So don't get confused. Air glass in the sense, here we have air, this is glass, light ray is passing from air to glass, that we have to call it as air glass. This one is air glass interface, and again this is refracted ray, and this ray is emergent ray. Emergent, this emergent ray which is passing from denser to rarer, denser means glass, rarer means air, so glass air medium. And last they asked, the emergent ray is dashed to the direction of incident. You see this one is incident, right? So if you draw incident like this, we can get this one is emergent ray like this. You can observe both incident ray and emergent rays are parallel to each other. Ray is parallel, you can write. That is the answer. 20th, the center of curvature of concave mirror lies in dash of it. This is concave mirror, non-reflecting side. This point is pole P, this is focus F, this is center of curvature C. What they asked, the center of curvature of a concave mirror lies in dash of it. Where it lies? Center of curvature lies in front of it, isn't it? It is lying in front of it. So answer is lies in front of it, not back. And last 5, fill in the blanks. According to the new Cartesian sign convention, the focal length of convex lens is dash and the focal length of concave lens is dash. Okay, this one is convex lens, principal axis. If a light ray is passing parallel to the principal axis after touching the lens, what will happen? It passes through focus. So here we have focus. According to the Cartesian plane, if you are moving in this direction, if focus is here, it is positive, right? In case of concave lens, which is also known as diverging lens, if a light ray is passing parallel to the principal axis, it diverges like this. But if you draw imaginary line, focus lies here. So if you are moving from optic center to the focus in this direction, you have to take it as negative. So a concave here, sorry, 21st, according to the new Cartesian sign convention, the focal length of convex, this convex is positive and focal length of concave is negative. So here answer what we will get? Positive comma negative. Next, 22nd, a concave mirror dash rays of light, where a convex mirror dash rays of light. Simple. In case of concave mirror, if light rays are passing parallel to the principal axis, all light rays will be converged. In case of concave mirror, all light rays will be diverged. So that is the answer. So a concave mirror converges rays of light, where a convex mirror diverges rays of light. So answer will be converges rays of light. Which one? Concave. And whereas a convex mirror diverges rays of light. 23rd, the dentists use dash mirrors to see large images of the teeth. So here what I told, in case of 7th one, the mirror used in construction of shaving glass. So why? Because we need virtual, erect and enlarged, where we can find in concave only. So answer for this 23rd question is also concave. mirror. 24. A transparent material bound by the two surfaces of which one or both surfaces of spherical form are. So don't get confused. First, a transparent material. So that material is transparent, bounded by two surfaces. So one surface, another surface, like this, two surfaces will be there. Of which one or both. So either one or both surfaces are spherical, means maybe you can find like this, two are spherical, or you can find like this, two are spherical, or you can find like this, one is spherical, one is normal, or you can find like this, one is spherical. Whatever you draw, what are these diagrams related to? Lens. That's it, answer. Last one, the degree of dash of light rays achieved by a lens is expressed in terms of its power. So what is meant by power? P is equal to reciprocal of focal length. Now, where we can find focal length? So here if you see focal length here, if you want to find focal length or focus, light rays will be converged or diverges, right? So the degree of convergence or divergence. So that is the definition of power in terms of degrees of convergence. So you see, one lens may converge at this point, another lens may converge at this point. So whatever it may be, power, they will go with diopters. So if you want to define power in terms of light rays, you have to go with the answer degree of convergence or divergence. Depending upon the convergence, divergence, they will set the power. So that's it. 25. Fill in the blanks in this chapter. Previously, I have uploaded 3 videos related to chapter 1, chemical reactions equations. So chemical reactions and equations, MCQs you can find, fill in the blanks you can find, true or false you can find in the playlist. At the same time, MCQs related to this chapter, light reflection, refraction, also you can find. You see, videos related to MCQs will be lengthy. So it is full length, maybe 40 minutes or 50 minutes video will be there, because we need to discuss nearly 20 to 30 MCQs. Okay, so this video and this video will be lengthy, and video which you are watching right now will be small, and this fill in the blank true or false is also small. Same thing will be applied for all the chapters in the science. Okay guys, if you like this video and if you feel this video is informative, you can read, and at the same time you can share this video to your friends. Until then, bye, have a nice day.